Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Faizullah, and in this lecture we shall study the complex line integral. So first of all, let us see the difference between the real integral and the complex integral. If we have to integrate a function f of x from a point A to B with respect to x, then in the real case, what do we mean? We mean that here f of x is a real valued function. Here a is a real number, b is a real number, and what does actually it mean? It means that we are integrating the function f of x from a point x is equal to a to another point x is equal to b, which is actually the real line. So in the real integration, we are integrating this function with the fixed real line. And now let us see that what we do in the case of complex integration. In the complex integration, first of all, we have to know that z is equal to x plus iota y is a complex variable, or x represents some complex plane. And from z is equal to x plus iota y, we can get the differential of z by dz equal to dx plus iota dy. And now if we have to integrate a function f of z, then f of z is again a complex function which can be written as f of z is equal to u plus iota v with respect to dz from a point z0 to another point z1. Now let us see what do we mean by this integral. Here z0 is a complex number, z1 is a complex number. If I represent this thing in the complex plane, then let z here z0 is equal to x0 plus iota y0, and x1 is equal to z1 is equal to x1 plus iota y1. So these are actually 2 points in the complex plane. So let us, the first point is here. I can also write this thing like x0 comma y0, and this one x1 comma y1. So let us say that this is our point x0 comma y0, and I have another point here, and this point is z1, which is x1 comma y1. Now if I have to integrate this function f of z, I need a path. So you can see that one option which I have is this curve, which is a straight line. So for the complex integration, I need a curve or a path of the integration. But you can see that I can also obtain another path. If I come from this point to here and this from here to at this place, then this one is another path. Let us say that this path is C2. This is the curve C2. And similarly, I can also integrate this thing with respect to another path. Let us say this is another path, and I say that this path is r of t. So you can see that we have many options to find the complex integral. So that is why for each complex integral, we always need some particular path. If someone say to integrate the following complex function, then we need some complex curve or some path for the integration. And now let us see from the screen that how we can evaluate the complex integral. So there are different methods. You can see that the first method is given on the board. In this method, you can see that C is some curve. If the curve C is given in the symmetric form, then we can use f of z is equal to u plus iota v, and similarly we can use dz is equal to dx plus iota dy, and then this complex integral along the curve C is given by 1, which you can see from the board. And now let us show you another method from the screen. The second method is, again we are given some curve C, and this curve is in the parametric form. So if the curve is given in the parametric form, then we can use equation number 2 to solve the given problem. In this method, r of t is given. From r of t we have to obtain r dash of t, which is differentiation of r with respect to t. And then we have to obtain f of r of t, and then we have to find the complex multiplication of f of r of t and r dash of t. And in this way we can solve different questions. So now I will solve some problems for you, and you can see that if we use any of these methods, you will get the same answer. So these methods are equivalent to each other. Another point which I have to tell you, that the complex line integrals are also called the path integrals or the contour integrals. And now let us solve this example. In this example, we are given the integration of some function which is z square, which we have to evaluate, and the curve is also given. The curve is a straight line which is from the origin to the point 2, 1. So first of all, let us use the first method to obtain the solution for this example. So in this example, let us see that integration along the path C of z square into dz. Now we are given that the curve starts from the origin. The coordinates of the origins, you can see 0, 0, and to the point 2, 1. So we can say that there is a point. So 2, 1 is another point. Let this is O and this point is A. The coordinates are 2, 1. And I have to obtain the integration along this straight line. So for this reason, first of all, I need the equation of the straight line. And the equation of the straight line, we know that any slope of, let there is some point P which is x, y. Now slope of any 2 points of the straight line is equal to the slope of any 2 other points. And we know that the slope is actually the ratio between the changes in the y coordinates into the changes in the x coordinates. So we know that for a straight line, that slope of PA is equal to slope of the line OA. And now from here we can obtain, let us find the slope of PA. This is P, this is A. y2 minus y1 divided by x2 minus x1. So we can find y minus 1 divided by x minus 2, which is equal to slope of OA. OA is this point. So again y2 minus y1 divided by x2 minus x1. So from this we can get that 0 minus 1 divided by 0 minus 2. And if we solve this thing, you will obtain that 2y is equal to x. Or I can write that x is equal to 2y. So this is the required curve or equation of a straight line. Now From the given question, we can see that here f of z is equal to z square. So if I put z equal to x plus iota y whole square, and if I evaluate this thing, I will get x square minus y square and plus iota 2xy. Now this is u, which is the real part, and this is v, which is the imaginary part. And now you can see that the integral of the function z square dz is equal to u plus iota v into dx plus iota dy. This is actually the value of the function. This is u and this is v. So from this I can write that this is x square minus y square plus iota 2xy and dx plus iota dy. And let this is equation number 1. Now from the given curve I can replace x by 2y. So just replace this x by 2y, this x by 2y. And similarly you can see that if I take the differential of both sides, I will get that dx is equal to 2 dy. And I can replace now dx by 2 dy. So if I put these things in 1, I will get that integration of z square dz is equal to, now x should be replaced by 2y. So let us write that this is 2y square, which is equal to 4y square, and minus y square now plus 2. Now let's replace x by 2y. So this is 2y into this y, and now let us replace dx by 2 dy, dy plus iota dy. And now let us simplify this thing. So if we simplify, now what we need? If we convert this equation into y-axis, then we need the limits of y from the given 2 points. So the limits of y are from 0 to 1. If you convert this equation into x-axis, then you should need the limits for x, which are from 0 to 2. But now it is in y, so the limits are from 0 to 1. And let us simplify this thing. So if you simplify this thing, you will get that from here we get, here is also iota, from there we get 3y square. Iota comes from here, okay. And this one is plus 4 iota y square into, let us take dy as common, so 2 plus iota into dy. And from here we can take y as common. So if I take y as common, I will get 0 to 1. This is 3 plus 4 iota into y square. But I have to write this thing here, 2 plus iota. And now y square comes here into dy. Now you can see that this is a constant term, and it is multiplication of two complex numbers. So if you multiply these things, you will get, let us start from here. After the multiplication, you will get that integration of z square dz along the curve C is equal to, from this we will get just like 2 plus 11 iota. Just multiply these two terms and take it outside from the integration, and you will see that you will get 2 plus 11 iota. And now we have to integrate y square. So integration of y square is y cube divided by 3. The limits are from 0 to 1. So if you put the limits, you will get that this is 2 plus 11 iota into 1 over 3. And this is the required solution for the given complex function along some curve. Now I have to show you that how we can use the second method, which is the parametric method, to obtain the solution. So the second method, method number 2, is method 2. Now we have already obtained that x is equal to 2y. From this we can get that x divided by 2 is equal to y divided by 1. So we have already obtained that x divided by 2 is equal to y divided by 1. And if we put this thing equal to t, we will get that x is equal to 2t and y is equal to t. And now what is r of t? R of t is equal to x of t plus iota y of t. Just put values in this one, so you will get 2t plus iota t. And from this you can get that this is actually 2 plus iota into t. And now we can use the second method. According to the second method, we need r dash of t. So we have to differentiate r of t with respect to t, and we will get that r dash of t is equal to 2 plus iota. Now the other thing we need, since we have f of z is equal to z square, so I need f of r of t. So r of t is this thing. So I have to write 2 plus iota all square. And if I expand this thing, I will get 4 minus 2 square is 4 plus iota square is minus 1 and plus 2 into 2 iota. So we will get 4 iota, which is equal to 3 plus 4 iota. Now you can see the integration of z square dz can be written as f of r of t into r dash of t dt. So from here I can get that f of r of t, this is equal to 3 plus 4 iota, and r dash of t, okay, this is equal to, and also r of t here is t, so we have to write t square here. So it means we have to write t square here. This is also t square. Okay, so now this is t square. And now we need r dash of t. R dash of t is this thing, which is equal to 2 plus iota into dt. Now these two terms are constant, so they will go outside, and if we multiply these two terms, again we will get 2 plus 11 iota integration from 0 to 1 t square dt. And if you evaluate these integral, you will get the same answer, which is this one. So integration along the curve c z square dz is equal to this thing. Now in the next step I have to show you the third method. The third method is that if you have to use this equation, but you have the curve in the parametric form, then how you can use this method to solve a problem where the curve is given in the parametric form. So let us see method number 3, and you will see that from all these methods we can obtain the same answer. So now you can see that here f of z is again given by z square, okay, and now f of z is equal to z square, and you know that this is equal to x plus iota y whole square, which is equal to x square minus y square and plus iota 2xy. Okay, and now the main formula is the formula is the integration of the function z square along the curve C is equal to, here I have to write u plus iota v, where this is u, this is v, and here I need dx plus iota dy. So now I have to put this thing here, and I will get that this is x square minus y square plus iota 2xy, and this thing is dx plus iota dy. Now the given curve, you can see that we have x is equal to 2t and y is equal to t. So just replace x by 2t and y by t. Similarly, from here, if I take the differential of x, I will get dx is equal to 2 dt, and from here I can get that dy is equal to dt. So just replace dx by this thing and dy by this thing in this formula. So let this is 1. So if I replace this thing, I will get that integration of z square dz is equal to integration, again this is from 0 to 1. Now x is 2t, so 2t square means this is 4t square. Y square, now y is t, so this is t square, plus iota 2, x is 2t, and y is t. And now dx is 2 dt and dy is dt. And now let us simplify this thing. So if now this is the usual integration, if you simplify and solve this question, you will see that the answer for this problem is 2 plus 11 iota into 1 over t. So you will get the same answer. So you can see that in all of these questions, we have the same solution. So now we have to solve another problem. The other problem, let us see from the screen. In the screen you can see that in example number 2, we are given that we have to integrate the same z square, but along some other curve. The curve is a unit circle, and the equation for a unit circle is r of t is equal to cos t plus iota sin t. So let us see the solution of this example. Now, in this example, we are already given the parametric form. So let us use that method, and we have r of t is equal to cos t plus iota sin t. By the Euler equation, we can write that this thing is equal to e power iota t. Now from here I need r dash of t. So just differentiate, and you will get e power iota t divided by iota. If you multiply this with iota by iota, you will get that this thing is equal to minus, this is differentiation, so the differentiation of r of t is iota e power iota t. Okay, now I have to obtain f of r of t. Now f of z is equal to z square, and I have to obtain f of r of t. So I have to obtain e power iota t whole square, which is equal to e power 2 iota t. And now I can use the method that integration of z square along the curve C, this is equal to integration. The limits are given, but the formula is f of r of t into r dash of t dt. So let us just put the values in this formula, and we need limits for t which are already given. So if I put the limits, this is from 0 to 2 pi, and f of r of t is e power 2 iota t into r dash of t. R dash of t is iota, I will write it outside, e power t dt. And now from this you can easily obtain that integration of the curve z square of the function z square along the curve c is equal to integration from 0 to 2 pi, and e power iota will be here, e power 3 iota t dt. Let us integrate this thing. So if we have to integrate this thing, we will get e power 3 iota t divided by 3 iota, and integration is from 0 to by the Euler formula you can see that okay, so this is from 0 to 2 pi. Okay, now just simplify this thing. Iota will cancel the iota, I will get 1 over 3, and by the Euler formula you can expand this thing. So by the Euler formula you can write that this is equal to cos 3t plus iota sin 3t. Integration is from 0 to 2 pi, and if you put the values, you will get that integration of this function is equal to 0 along the given circle. And now I have to show you from the screen another problem. In this problem you can see we have to evaluate some complex function. The limits are given from 0 to 1 plus iota. So I have to just give you some hints. Here again z is equal to 0 mean the origin 0 comma 0, and z is equal to 1 plus iota mean 1 comma 1. So if these are 2 points, one is 0 and the other point is 1 comma 1, which is p. So using the method of the previous example, you can obtain a curve which is y is equal to x, and if you use the same procedure, you will get that the answer of this problem is minus 1 over 3 into 1 minus iota. But just try this by yourself. And let us see the other part of this example, which says that we have to evaluate the given function along the path from z is equal to 0 to z is equal to 1, and then from z is equal to 1 to z is equal to 1 plus iota. So if you evaluate this, from the first of all you have to obtain the equation of straight line, which is from origin to m of 1 comma 0, and using the same procedure you will get that the equation is y is equal to 0, and you will get this answer. Similarly for the next point, this is m and p, you will use the same procedure, you will get x is equal to 1, your curve, and then using the same procedure you will get this solution number 4. Now adding 3 and 4, you will get the answer for problem example number 3, part number 2. Now these are some questions, and by using the concept which we have learned in this lecture, you can solve all of these questions. So till the next lecture, Allah Hafiz, Assalamu Alaikum.